Welcome. In this session, we'll see how to model the switching action in circuits or networks by using unit step signal. Let's start. First of all, what do we mean by switching action? Switching action simply means the turning on and off of a switch. So switching simply refers as turning on or off the switch. And why do we do that? This simply means when we want to connect a source to a source or switch off a source or connect a source to a network. That's meant by switching. Now, to illustrate this switching concept, let me take a simple example of an RC circuit. Let's suppose we have an RC circuit. Capacitor, and we want to connect this circuit to a source V of S, and that's a voltage source V of S. And what we can do, we can use a switch to do that. Means to connect to this, means to connect to this this RC network to the source, we use a switch, and that switch is written shown like this arrow. So suppose we connected this switch at t equal to 0, means we turn on this source or connected this source at t equal to 0 to this network. All right. So before t equal to 0, the circuit looks something like this. So for t less than 0, the circuit looks like this, means and for t greater or equal to 0, the circuit looks like this. So for t greater or equal to 0, the circuit looks like this. So now this source is connected to this RC network. All right. So this circuit is valid for t less than 0, and this circuit is valid for t greater or equal to 0. Now what we want to do, we want to represent this turning on and on off of the switch, means this switch that is this switching action, and that is represented by this. And for this, to do the analysis of this circuit, we have to draw it like this, means for t less than 0, the circuit that's valid looks like this, and for t greater or greater than 0, greater or equal to 0, the circuit that's valid looks like this. Means we have to use two different networks or circuits if we have to do the analysis of the circuit. So how do we replace these two circuits by a single circuit that is valid for all time t? And that we can do by using this unit step signal. We know the definition of the unit step signal, which is denoted by u of t, is given as if this signal is equal to 1 when t is greater or equal to 0, and for t less than 0, the signal is 0. So this is the mathematical definition of this unit step signal. And we can also plot this signal. Graphically, the signal looks like this. If this is the time axis and this is the amplitude axis, this is u of t, the signal becomes equal to 1 when t is equal to 0, and for t less than 0, the signal is equal to 0. So this is the graphical definition of this signal. So we can use this signal to model this switching action, and the circuit that we can draw by using this unit step signal will be valid for all time. All right. So let me show you how. So this is the same RC circuit. Only difference is V of S is now replaced by V of S, U of t. So this is the same RC circuit. Only difference is now the source is replaced by V of S, U of t. Now have a look at these two circuits. This circuit, if when t is less than 0, so this u of t will be 0, means the source is 0. That's same as this, means no, nothing is connected to this, means the source is not connected, means this model is this section of the circuit. when t is less than 0. For t greater or equal to 0, u of t is 1. So this will be simply v of s, and that's same as this. Means this circuit now is valid for all time t. So this circuit is valid for all time t. And we can do the analysis of this circuit for all time. So that's how we can replace this when this turning on and off of a switch by simply using this unit step signal. Now, next point is it always necessary that we turn on or off this switch at t equal to 0? We can turn on this switch at any time t. Suppose t is equal to 1, t is equal to 2, t is equal to -1, t equal to 0. So in general, if we want to turn on or off this switch at t equal to t naught, how do we represent this switching action by then? All right. So what we can do, we can use the shifted version of the unit step signal. We know the shifted versions of this unit step signal looks like this. So suppose it is u of t minus t naught. So the definition of this signal looks like this. It's called 1 when t is greater or equal to t naught. For t less than t naught, the signal is for t less than t naught, the signal is 0. So this is the definition, and we can use this. Now, so the switching action like this, and now we are turning on this switch at t equal to t naught. We take the example of the same RC circuit. Here we are connected this. So this is open circuit at t before t less or equal to 0. So for t less than 0, this switch is open. So this is the circuit that's valid. Now for t greater or equal to 0, so the switch is connected to this RC circuit, and we can write it like this. So this is V of S R, and this is the circuit that's valid for t greater or equal to t naught. All right, so this is the circuit. Now what we can do, we can combine these two circuits in a single circuit like this. We can have this R and C now connected to a source, which is V of S, U of t minus t. All right, so this is a R and this is C. Now when t is less than t naught, we know that this U of t is 0, means this source voltage is 0. That is same as this circuit. When t becomes greater or equal to t naught, U of t is 1. So this is same as V of S, and that is same as this circuit. So we can perform the analysis by using now this circuit, which is valid for all time t, which is valid for all time. I hope you have got the idea how do we model the switching of the circuit or turning on and off of a switch by this unit step signal. Let me stop here.